Okay, let's look at 11D. I tried to get started on it in class, but I wasn't quite able to get it to work out. So I've got the graph, and it's a cylinder, but there is a hole in the center, so we're going to do the washer method. What threw me off was the rotating around the line x equals 6. So if we just focus on this bit until we get to that line of rotation, so just this side, the outer radius is, I'm going to do the entire outside of the curve. So I want from 6, so r of y is 6 minus the function, so right minus left, the right part is the axis that we're rotating around, minus the left, which is the curve, y equals square root of x, or y squared equals x. And we're doing everything in terms of y because x equals 6 is vertical like the y-axis. So this is pi, interval 0 to square root of 3, and our outer radius is 6 minus y squared. Now our inner radius is the hole, and the hole is from 6 to 3. So its right part is 6, and its left part is 3. And we subtract those, we get 3. So outer radius minus inner radius. So then we would just clean up this. We're going to square this and get 36 minus 12y squared plus y to the 4th minus 9 dy pi 0 square root of 3. Excuse me, 27 minus 12y squared plus y to the 4th. You may not even want me to do this last bit since we're just integrating. So pi 27y minus 12y to the 3rd over 3 is 4y to the 3rd plus y to the 5th over 5 from 0 to square root of 3. So plug in square root of 3 and we get 27 square root of 3 minus 4 times square root of 3 cubed frees one of the, a square root of 3 times one of the square root of 3's gives us a normal 3. But we still have a 3 under the root. And square root of 3 to the 5th gives us a normal 3, another normal 3, but we still have a square root of 3 over 5. So I'm thinking through square root of 3 to the 5th. So these give us a 3, and these give us a 3, but we still have a square root of 3. And then that would be 27 square root of 3 minus 12 square root of 3 is 15 square root of 3 minus 9 square root of 3 over 5. Then we want to get a common denominator. So that would be 75 square root of 3 minus 9, which is, plus 9. 75 plus 9 is 84 square root of 3 over 5 pi. So that one is complicated. That one is difficult because the washer method, because it's a vertical line, axis of rotation. It's got several things going with it for it to make it a little more complicated. And then I also wanted to do number 14 on AP review. And we have the picture. Okay, so number 14, they said that G was an antiderivative of f such that g of 2 was 5. They wanted to know how many c's there were between 0 and 6 to where g of c was 3. And Abby was on there at the start. And Abby, you may have got yours to work out. And I was just going to split it up and do area instead. So from 0 to 2, it would be g of 2 minus g of 0. And for this side here, I would find the area between 0 to 2, which is this rectangle. With this triangle. So it's 1/2 base times height. G of 2, they told us, was 5. And I don't know g of 0, but I can get g of 0 by itself. What if we move g of 0 over here, and we moved this 1/2 of 2 times 2? 1/2 of 2 is 1, so that's 2. So g of 0 is 3. So there's one value. That's 1c. When c equals 0, g of c is 3. So there's one of them. I'm just going to start to build a little g graph. At 0, we're at 3. Alright, now in this little section, there's this nice turn here at 4. So how about we just look at this area right here? That'd be the area from 2 to 4, which would be g of 4 minus g of 2. And this area formula will be the triangle also, except it's negative because it's below the axis. Negative 1/2 base times height. G of 4 we don't know, but again we know g of 2 is 5. So g of 4 is 5 minus, if I move the 5 to the other side, 5 minus 2 is g of 4. So g of 4 is equal to 3. So there's another value. When c is 4, g of c is 3. And so if I wanted to sketch that before, we would be at 3 again. Well, what's happening is on the f function, this is decreasing. So that means, let's see, let me get that right. From 0 to 2, let me break that up. So from 0 to 2, we're positive, which means we're increasing till 2. And then from 2 to 4, that's a negative area, so that means we're decreasing, and we know we decrease to 4. And then let's also look at the interval from 4 to 5. That's g of 5 minus g of 4. 4 to 5 is another little triangle. That's a negative 1/2 base times height. G of 5 we don't know. We did just find g of 4 to be 3. So g of 5 is 3 minus 1. G of 5 is 2. So g of 5 is 2. And this is still a negative area, so we're still decreasing. And I'm really running out of room, but let's do it up here. We have one less region to look at between 5 and 6. So that's g of 6 minus g of 5. Between g of 6, that's a positive area, 1/2 the base times the height. G of 6 I don't know, but we just found g of 5 to be 2. So if you add 2 to the other side, you get 2 plus 2, which is 4. G of 6 is 4. So at 5, we're at 4. I'm sorry, at 6, we're at 4. That's positive, so that means our function's increasing. Well, we found two spots where g of some x value was 3. And because this thing's continuous, there's going to be another between 5 and 6. And if you're taking the exam, that's using the intermediate value theorem because it's continuous. And because g of 4 is 2, and g of 5 is 2, and g of 6 is 4. Therefore, there must be some c value between 5 and 6, such that g of that c is equal to 3. So that's the intermediate value theorem. So that's how we can get that there are 3 values there. That one's a tough one.